In today's lecture, I will introduce one of the popular tool used in the cloud computing, that is called as CloudAnalyst. So this CloudAnalyst, you can see this paper is published by Professor Kumar here from University of Melbourne, Australia, right? He and his group of students have developed this particular tool, although they have discussed the CloudSim tool also. Okay, so here you can see in the title they have mentioned CloudAnalyst, a CloudSim-based visual modeler for analyzing cloud computing environments and applications. So CloudSim I will introduce later, right? And because CloudSim requires a little bit more knowledge to know about the CloudSim. But if you go for the CloudAnalyst, it is a visual modeler. As it is a visual modeler, what you can do, you can simply click the options and select the things as per your requirement, and accordingly everything will be processed in the CloudAnalyst. So you can say it is having a good graphical user interface. So this GUI enables the user to use the various services of the cloud, or in fact you can request some services to a particular data center, and how it is allocated to the data center, who is going to allocate, how much time is required to allocate the data center. Each and everything you can see by the help of this CloudAnalyst tool. Okay, this CloudAnalyst tool. Many researchers also have modified this CloudAnalyst tool, and but it is all the things are not incorporated in this tool because the primary version is available in the internet. If you download the primary version, there are few algorithms are already there. We are going to discuss that algorithm. Those who want to work in this particular domain, they can simply change the code and check whether the newly developed algorithm has some advantages or not. Right? You can see in this platform. As you know that setup of anything is very difficult, right? Whenever we want to develop a particular software, it is not possible to go and develop each and every module of that particular software. Right? It is difficult, right? So in fact, what you can do, somebody will tell you if the particular software is having 5 modules, right? And you are interested to modify one module. So what you can do, you can modify a single module and keep other 4 modules as it is, right? So that what will happen, developing the entire software will take less time, right? What you are doing, you are improving some module, and you are just integrating, you are removing a particular module, you can say, or you can add a particular module by keeping other modules as it is, right? You are not going to modify each and every module because you are not interested for that, right? So similarly, whenever you go for development of cloud, right, it is not practically possible to develop each and every module whenever we are looking into a particular tool, right? It is not possible, right? So what you can do, whatever things you are interested, suppose somebody is interested for resource allocation, somebody is interested for the task scheduling, somebody may be interested for the architecture, somebody may be interested in the network delay, okay, network management part. So that part only you have to modify. Rest part you have to keep as it is. So that what will happen, the modification will take less time and building the complete software is more easier now, right? Because other modules are not changing. The newly developed software is taking less time, right? In that manner, you can see CloudAnalyst is a very famous one. A lot of algorithms are developed, but I am not going to discuss all algorithms. I will keep on discussing only the basic algorithm, whatever available in the CloudAnalyst, right? So in order to install CloudAnalyst, what you can see, I am showing a folder. So you can see here. Okay, let me show you what are the things required. I will select these things so that you can install in your computer as well. So for the CloudAnalyst, you require NetBeans, right? NetBeans, I have some version. You download the updated version. You also require JDK, right? JDK is required. So if you don't have, and most of the computer is having JDK. If you don't have, you can also download the latest JDK, right? These two things are required to run the CloudAnalyst in your computer system. Not necessarily database, it may be any Java software. Okay, you can use to run the CloudAnalyst. So what you basically will do, first you will open, let me close this one, then you can see the complete demo. So first, once you install NetBeans and JDK, what you will do, you will open the NetBeans. First, you open the NetBeans. It will take a little bit of time to open the NetBeans IDE. So once you have done with this one, NetBeans okay. I will save this particular folder. This is the CloudAnalyst tool, right? That is available. The size is very small. So it is only 3.7 MB, right? I will save this folder, or otherwise you can also download this thing from the internet. It's available in open source, or you can visit to Professor Kumar website, and you can download this cloud_analyst zip folder, right? Okay, I will provide you. There is no issue, right? Then what you have to do, you have to build a project. So you have to write open project. So you have to locate your CloudAnalyst wherever it is, right? And if you are in the desktop, you go to your desktop and select that folder. If you are in any other position like CPD drive, any subfolder is there, you please locate this cloud_analyst zip file. Then you can click open project. So it will take a little bit of time to open the project. Let us wait for a minute. Then let us see what is the outcome is coming. Okay, it is coming here, right? So CloudAnalyst is there. Inside CloudAnalyst, you have two folders. One is source packages, okay, and it is your libraries, right? So these are the these in the source packages. You can see there are a lot of extensions are there, right? Like for the data center, some module is developed, GUI, or you can say service developer, network, utilization, util, and STAP. Lot of things are there. Each and every module is there in the cloud package. So let us go to the inside of the data center just to show you what are the things and living in the data center. So you can see here active VM load balancer for Java, one file is there. Data center controller is there. Round robin, one of the very popular algorithms is followed in operating system. So similar kind of similar algorithms is also available in the cloud scheme. Total VM load balancer is another algorithm. Virtual machine state and VM load balancer. Suppose you are interested to modify the round robin VM load balancer. So what you will do, you have to click it. You understand this particular code, right? And simply you modify the things whatever you require without modifying other modules. What will happen? You are changing only a single file, right? Single file you are changing, left file you are putting KJP, right? So if you will see, you are only with modifying a single file, it will be here, right? Rest modules are not modified, and you can also if you are incorporating your own algorithm as a big project, so what you can do in a big project, so very easily you can do, because one Java file you have to incorporate, and you can check the performance with the existing algorithm, because the existing algorithm performance is already there in this CloudAnalyst. Only you have to integrate your file and you can check the performance, right? Okay, so we'll go details about this thing later. Just I will show you the details of this CloudAnalyst tool, how this graphical visual model is working. Okay, let me run this one, right? Let me close this thing. This thing is not prepared. I'll do details. So I'm running this one. Once you have located your particular path, you will see in the project it will be available. Like whenever you are creating a Java application, you are creating a project, and inside that you are doing the things. Similarly, in this case, CloudAnalyst you have to locate and you have to run it. will take few time. Okay, now it is coming, right? So this is the graphical user interface that is available in the CloudAnalyst, right? So you can see this is nothing but the world map, right? This is the world map, and you can see here we have two dots, right? Two dots. One is red color, another is blue color. Red color it is written as DC1. DC1 stands for data center 1. Okay, and blue dot indicates it is UB1. UB1 means it is user base 1. User base 1 is nothing but our user request. In the resource allocation, I told you that each and every request is treated as a lead, right? You are submitting a set of leads, and these leads are allocated to the resources. Like we discussed about 4-node cluster. Whatever leads a user is submitting, we are assuming that is there is a 4-node cluster is available. Within that 4-node cluster, we want to manage the request. A lot of algorithms like this, right? Similarly, this user base is nothing but a group of requests. Group of requests is initiated by a user, right, or a particular organization, and they need some resources of the data center. As they need the resources of the data center, okay, once you run this simulation, what will happen? These user requests will run in the data center. Okay, so when this request will run in the data center, so it will take some time. You have to pay that cost. Okay, as per the service level agreement. So these things will be, you can see these things will be automatically generated as the configuration is already there, right? Only you will see how it is working and which algorithm they are used to execute it, right? And apart from this world map and these 2 points, you can see there are 5 buttons available. One is called as the configure simulation. Second is your define internet characteristics. Third is run simulation. Fourth one is exit. So if you want to exit this thing. And fifth one is nothing but the flow region boundaries. So whenever we discussed about the Amazon S3, we have seen in Amazon S3 there are lot of regions are there, right? Amazon divided the whole world into various regions. The reason is that with respect to the region, the laws and regulation is different. With respect to the region, the capacity load may be different. With respect to the region, there may be, you can say, the way that the user request is generating, the user request is solved, they are also different. So with respect to various regions, the policies may be different, right? So once you click the show region boundaries, it will show the world map into various regions. So here you can see the total world map is now divided into 6 regions, right? You can see here, first region is here, that is R0, right? Region 0, where the data center is there. This is your region 1, okay? This is your region 2, where your user base is there, right? This is your region 3. In fact, India is coming under the region 3. You can say the region 4 is here and region 5 is here, right? So they have divided this into number of regions, okay? So you can also, whenever you want to develop a new tool, what you can do, you can go for more regions, right, if required, right? But as for this configuration, they divided the whole world map into 6 regions, starting from R0 to R5. Because if sometimes the laws and regulation, let us see the region 0, some here a data center is there. Suppose somebody will say that only this part they have the same rules and regulations, same laws and regulations, same legislations as well, right? So what will happen? The data should not go the boundary of region 0, right? If you say like that, then you have to develop an algorithm such that the allocation of the user bases to the data center will be done in this region only. It will not go outside this particular region, right? That is the reason why they have divided into multiple regions, right? Because once the data is going outside this particular region, they may feel that the data leakage will be there, or serving the request will take also more time, right? If the distance is more, you know that the communication time will be more. So if the communication time is more, it will impact your performance, right? So the region of this button, if you see, show region boundaries. And if you want to see the regions, then you can click this button. Otherwise, it is not required, right? So once I deselect it, then it will go to the previous one, right? Once you click it, again it will show the region, and once you will click it, it will only show without any region boundary. There is no other difference, right? And you know that this is a very when you done with the simulation, you can click this exit button to terminate everything and back to the NetBeans screen, right? Okay, so you can see here also help button is there. If you click about, then you can see it is a cloud simulator. That is the version is 1.0 created by one of the person for University of Melbourne, right? But yeah, that we created this particular simulator, but in fact it is done by a group of people of University of Melbourne under the guidance of Professor Kumar, right? So let us see these three buttons specifically I will discuss in this class, right? So that you will be familiar with this tool. Okay, first we will discuss about the configure simulation, then we will go for the defined internet characteristics, then we will discuss the run simulation part. In fact, it is very easy. Once you click run simulation, whatever configuration you have set here, whatever you have defined in the internet characteristics, based upon that, the algorithm will work. Okay? There is no other purpose of this run simulation. So out of these modules, if you see, once you understand these two, that is configure simulation and define internet characteristics, then what you can see, you can understand this particular tool, and you will know what are the algorithms available and what kind of additional work you can do in this tool to say that if you are doing any particular project, your project is better than whatever things available in this particular tool, right? Whatever algorithms available, if you are developing a new algorithm, then you can compare your algorithm with the CloudAnalyst algorithm, right? So let us go to the configure simulation. I am clicking configure simulation. Once you click configure simulation, there are three things. One is your main configuration, okay, where you can decide the user base. You can specify the link and various things related to the user base. There is a data center configuration where you can set the things that are required in a particular data center, or whenever you are set up a particular data center in a particular location. So what are the parameters we need to consider? The third part is our advanced layer, right? So these are the three things we have to set in the configure simulation. Let us go in details. So this main configuration, you have to select some simulation duration, because whenever we are claiming that one algorithm is better, or whenever we are claiming that uh, our algorithm is better, or whenever we are comparing our algorithm with other algorithm, we need to run the simulation for a particular period of time, right? So generally what happens in cloud, we are running a particular simulation for 48 hours, 72 hours. So out of 72 hours, we are comparing two algorithms performance, how they are behaving, right? That is the experimentation part, right? Experimentation part means your real server is there. You have developed the algorithm based upon that algorithm. The work are distributed over the server, and the servers are doing their work to for a particular period of time, right? But doing such type of simulation is very difficult for an academic purpose, because we don't have so much servers to test any algorithm. So we are relying on a simulation. Like CloudAnalyst is giving us a simulation. This is not an experimentation, it is a simulation. Okay. So where we are creating a virtual environment. We are not going for the actual environment, because experiment part we are going for actual environment, but CloudAnalyst part we are going for our virtual environment. Whatever we are seeing in the actual environment, the same thing we want to check with the simulation, right? If it is fit in the simulation, then the same algorithm can be extended to uh, other means it may be generalized to your experimentation, right? So you can see here, you can set the simulation duration. It will be 60 minutes or 60 hours or 60 days. Okay. So based upon the type of applications and based on the type of analysis, you can select one of them or you can reduce the time also. Suppose I want to do the simulation for 10 minutes, right? So you can select this thing, right? Wait for your requirement. So you can see how what is a user base. User base has the following couple, right? You can see, you can specify the name of the user base, right? You can edit the user base name, and you can also specify the where the request is initiated by the user. That's why you can see the regions are from 0 to 5. I told you total number of regions is 6. It is starting from R0 to R5. So whenever you are specifying maybe 1, so you have to specify in which region this user request is there, right? Suppose by default you have seen, if I go to the previous one, you can cancel it. So you can see the UB1 is available in the region 2, right? But if somebody wants the UB1 should be available in the region 0, simply what you can do, you can select region 0, you have to click done, then it is available in the region 0. What it indicates, a user is requesting the data center, one of the data center, right? Like here it is only one data center is there. So a user is requesting at the data center and both user base and the data center one is available in the same region, right? So such type of configurations you can select here. I told you user base is nothing but a set user request, right? That's why you have to select the request per user per hour. How many requests is generated per user per hour? For example, 60 requests is generated per user per hour in user base 1, right? And the amount of data per request also you can select here. So it is by default some values are there, these values you can select, right? And I told you about the pricing mechanism. We discussed about the fixed max price, fixed min price, Libra plus dollar price, Libra plus dollar auto price, min price, max price, many things we discussed, right? So where if you see the overall concept says 24 hours is divided into two parts. One is one peak hour, another is called off peak hour, right? So generally in the off-peak hour, the resources are not occupied, and the peak hour, the resources is occupied, right? Off-peak hour, even if the resource is occupied, they are not utilized properly. So what we are planning that how we can utilize that resources by providing the resources to the users with less cost in the off-peak hour, right? That's why you can also select peak hours start at GMT time. You have to specify peak hours and at what point of time, right? Within that peak hour, that is called as a peak hour, right? Rest is called as an off peak hour, right? And how many users are there in the user base, that also you have to select. Average peak users you can select here. Average off peak users is 100. Means in the peak hour, the users average is, if you see, 1000 number of users are available, but in the off peak hour, only 100 users is available, right? So for example, I will tell you a very simple thing. I want to add another user base, so I will click add new. I am creating user base 2 and it is available in the region 1. I want to initiate this user base, okay, in the region 1. Similarly, I am adding another one and user base 3 it is available in the region, right? Similarly, let us add another one, user base 4. User base 4 is available in the region 3. So with respect to each and every region, just I am creating one user base. So as for your requirement, what you can do, you can add the user base, right? So let us add another user base with region number 4. Let me add another user base with in the region R5, right? So now if you see, if I click done, you can see with respect to each and every region, you have a user base, right? R0 region user base, R1 case you have UV2, and okay, R2 case you have UV3, and R4 case it is UV5, R3 case it is UV4, and R5 case it is UV6. Now successfully we have created one user base in one table, right? You can create multiple user base with respect to one region, because you know that in a particular day, in a particular region, what happened, the number of users accessing to the internet or the cloud services is more, right? In that case, we are assuming that the user bases are multiple number of user bases are available in a single region, right? So, okay, so these are the things we have created in the region. Now, I think this part is clear to you that user base, you can select, you can change these values as well, right? But I'm keeping it for the time constraint, right? So the second part, you have application development configuration. In the application configurations, you have to specify the data center. I told you the data center has a lot of servers. In each and every server, you can create multiple virtual machine as per the capability of the servers, right? So here you can see there is a single data center element, and the number of virtual machines you can create in the data center is 5, right? You can also change this value to 10, 20, something like that, or 100, something like that, right? And image size, I told you whenever we are sending the data from one data center to another data center, or whenever you want to pause these things, you are taking an image of the virtual machine from one physical machine and you are doing the same in another machine, right? In that case, what happens? You are creating a disk image, right? One image is created, that image needs to send to other server so that the work can be resumed from that point onwards, right? So here similarly the image size is written is 10,000. The memory available in the data center is 512. Bandwidth is required is 1,000, right? So similar thing is there. So if you want to add the data center, you will get an error, right? So it is saying all available data centers seem to be allocated. Please create a new data center before you can create for the allocation. That's why you can see here there is a data center configuration tab is there. In the data center configuration tab, what you can do, you can set up the data centers. Okay, you can set up the data center in the data center configurations. So if you want to add a data center in this point, if you want to see in the visually, then first you have to go to the data center configuration, and in the data center configuration, you have to create the data center. Then only you can add a new data center in this location. Otherwise, you will get any kind of error, right? So before going to this data center, you have another thing here. You can see that there is a server broker policy. So there are 3 server broker policies are there. One is called the closest data center. Second one is called as optimized response time. Third one is called reconfigurably dynamically with load, right? So there are 3 algorithms are there. As the name suggests, closest data center. Closest data center means you can see if you come to here for user base 1, which one is the closest data center? The closest data center is our DC1. Generally, you can see whenever a user base is initiated, the data center which is available in the same region can be treated as the closest data center. For example, UB6 case, what is the closest data center? For now, you can see in this particular one, you have a single data center. So for all the user bases, what happens? The closest data center is this one only, because you have only one data center one to execute your request, right? That's why multiple data centers are deployed in various locations so that one data center should not be overloaded, right? But if such a scenario, if this particular scenario is there, irrespective of the user base, what will happen? All are need to be executed in the data center one only, because that is the only one resource available in this scenario, right? So let us go to the configure simulation again. So the closest data center means the user base. We'll see the location of the user base, and we'll see the data center locations, and we'll find the closest data center, okay, which can execute that request. The reason of going for the closest data center is that the laws, regulations, or legislations, or the communication, if you see, more or less these things will be easy to solve if it is there in the same region. But it is not always good, right? Maybe data center is not always good. That's why we have to go for some other algorithm, like we are going for optimized response time. Because what will happen if you say closest data center, if in a particular region, let's say in this particular region R0, there are multiple user bases are there. So let me say there is another user base 2, user base let's say 10 is there, user base 11 is there, let's say another user base 12 is there, right? If such a things will be there, then what will happen? So this user base 1 is dependent on DC1, user base 11 is dependent on DC1, user base 10 is dependent on this one, user base 12 is also dependent on DC1. So if all are dependent on the DC1, then what is going to happen? Data center 1 is overloaded. That's why this closest data center, the first algorithm, that is closest data center algorithm, is not good, right? It is good if the load is equally there in each and every region, right? Whatever load is there in each and every region, if you can assume these loads are more or less same, then you can say closest data center will perform better, right? But in real life scenario, it is not yet. In the world, you can see in all over the world, the population of each and every country is not same. The population of the regions are not same. Right? The people who are accessing to the cloud, they are not same. Right? That's why closest data center policy may fail. The solution is that we are going for the next one, that is called as optimize response time. Optimize response time. Okay. The reason of going for response time, we have studied in the operating system. What is the response time? Response time is nothing but the first response, right? Whenever you are requesting something, right, to the cloud, when you are getting your first response, that is called your response time. Whatever we studied in the operating system, right? But what we are doing here, we are a similar concept is used, right? So whenever you are this user bases, right? Like here I told you that UB1 is there, UB10 is there, UB11, UB12. When we are going to allocate a particular data center for these user bases, we are not only see the response time of this data center, we are going to check the data nearest data centers as well. For example, for the UB1, another possibility, let's say there is another data center here, a data center name is let's say DC10. So what I will check? I will check user base request in the data center 1, user base names request in the data center 10. So I will find what is the response time if I will going user base to the data center 1, and also we are going to see if the same user base 1 is assigned to data center 10, what is the response time. Okay, and wherever we are getting the good response time, or you can say less response means quick response time, we are going to assign to that data center, right? So that is the very important part, because sometimes what happens, the closest data center may not give you the good response time due to overloaded request, right? So what you can do, you can move from one data center to another data center, right? Obviously, you are going to check other policies like security policies and other policies are there. But optimized response time says if a data center is far away from you, but it is giving the quick response time in comparison to your closest data center, then what you can do, you can go for that data center. That is called as our optimized response time, right? So obviously, optimized response time will give a good performance from the closest data center. Okay, there is a third one is available, that is called as reconfigure dynamically load. This is reserved for the future one, right? Sometimes what happens, we are changing the topology, we are changing the network configurations so that we are going to achieve good result while processing the request in the data center, right? So such type of things will be incorporated in future. That's why there is a reconfigure dynamically load service local policy there. So generally, the idea of this broker policy is how you are going to assign your user request to the data center. On what basis you are going to assign to the data center, right? So that is determined by the service broker policy. So what is the advantages here? Suppose you develop a new algorithm, which is the service local policies. So what you can do, instead of these three things, here four things will come. Let's say the last one is the proposed algorithm. So you are not changing other configurations. Whatever other configurations is there, that is there as it is. So you are not editing any part, right? Based upon your requirement, you can create the user base, but you are not going to develop how user base module is developed or how this application development deployment configuration is developed. Rather than you are only focusing on the service broker policy. Right, that is the advantages you are going to get if you are using this particular tool. You are only changing whatever required. Whatever things are not changed, but will be as it is, so that a comparison is easier and developing a fulfilling your need is also very easier, right? So this is all about the main configuration. Let us go for the data center configuration. In the data center configuration, you can see the properties of the data center. Data center is also deployed in a particular region. You can select another region. So once you select a particular data center, you can see something is active here, that is which is showing the physical hardware details of the data center, right? You know that data center has a lot of servers or virtual machines you are creating on top of the servers, right, or the physical resources. So the details about the data center one you can find here. For example, you can see here, you can say data center one has two different servers, that is one ID is 0 and ID is 1. The amount of memory available in that server, the amount of storage available in the server, available bandwidth, how many processors are there in the server, what is the speed of that server in MIPS, that is listed here. And there is two type of policy is used. One is called as your time set. You are setting your time, and there is the space set policy. Right? Two policies there, but here I think only one policy is available. That is the time set policy. But if you go to the documentation of the CloudAnalyst, you can mention two types of provisioning you can do in policy provisioning. One is you can save the time, right? The same time it can be used by multiple user, or the space, this means your storage or memory, whatever you are using, that also you can save on multiple user. So such type of VM policies also you can select here. And you can see here also the data center one is having the architecture. The architecture is called as x86 architecture. We are having two architecture. One is x86 and one is x64 architecture. Right? I told you in the very beginning classes. So here it is only one option is available. One is x86 architecture. It is loaded with Linux operating system. It is taking the virtual machine monitor with XCM. We discussed multiple virtual machine monitor. Like I told you about VMware, right? I told you about KVM. Similarly, another virtual machine monitor is XCM, right? So that virtual machine monitor is used in the data center one. What is the cost for VM? If you are using the resources in the data center one, if you have deployed a virtual machine in the data center one, what is the cost for virtual machine? Dollar per hour, that is listed here. You can change this values as well. What is the memory cost? What is the storage cost? What is the data transfer cost? How many physical hardware units are there? Suppose I am changing it to 4 hardware units, right? I am going to add this is a 4 hardware units, right? So we change to 4. Okay, it is not working because it is the default configuration of it. Okay, let me change for the new one. New one I am changing 4. Okay, so the similar things you can add here physical units. I do not know why it is not working, but you can add number of physical units. You can see here whenever you are clicking the data center one, you have 2 physical units, but when you click the data center one, you have only 1 physical unit, right? So let me create with respect to one region. I want to create, let's say in the region one, I want to create a data center. I'm adding another data center in which I'm creating in the region number 2. Okay. So let me try whether it is working or not. Right. Okay. When I'm adding another one, yes, now it is working. Right. No. Okay, that is the purpose of doing these things, right? So data center 4 I want to create in the region number 3. Similarly, I want to create a data center 5 in the region number 4. I want to create another data center in the region number 5, right? So with respect to each and every things, you have a data center. So once you click done, you will not see the data center. You see here only one data center is shown, right? It is not showing all the data center. What you have to do, I told you, once you configure this data center, you have to come to main configuration. Under the application deployment configurations, what you can do, you can create a data center. Like I am ready data center to here, data center 3, okay, data center 4, data center 4, I can create another one data center 5, I can create another data center which is DC6. Okay, so now if you click done, then you can see you have data center. Like we created one user base per region. Now the data center of each and every region is present. Like region 0 is having data center 1, region 1 is having data center 2, region 2 is having data center 3, region 4 is having DC5, region 3 is having DC4, and region 5 is having DC6. Okay, so with respect to each region, we have created a user base and data center. You can create multiple user base. For example, let me add another user base in the region 0 so that we will get a clear picture. Okay, that is done. So you can see two user base is available in the data center 1, and you have one data center per region and one user base per region, right? Now this is the case. Here also what you can do, I told you something also in the network, you find something called primary and secondary, or there is a backup one, right? Sometimes whatever if the primary fails, then we are switching to the secondary. So what you can do, this data center 6 I am creating a copy. Okay, number of copies I want to create, let me I am creating 4 copies. What it indicates, the same thing is copied 4 times, right? So that you can launch one as a primary, another you can launch as a secondary, right? Such type of concept also you can incorporate by the clicking this copy, right? So now I hope I can modify this. So you have to create it, after that only you can modify, right? If you want to go for data center 2, let me data center 2, I want to create a copy. Select the nation, okay, I'm selecting the nation, data center 2. I want to create a copy. Okay, this machine's copy I want to make. Let me create 10 copies, right? Okay, you can see 10 copies created. Then you can see if it is updated as 11, right? So in order to update this physical hardware unit, you have to depend upon, you have to first click a particular thing and create its copy so that it will be automatically updated there. Like you can see here, I have created 2 copies in the data center 2. So once I click the data center 4, then it is updated as 3, right? So this is your data center configuration. Next is the last step is your advanced step. Here what you can do, user grouping factor is there in user base, right? How many that is nothing but equivalent to the number of simultaneous users from a single user base. So you can do that too, right? How many users can be grouped into a single user base, that you can decide, right? Similarly, there is a request grouping factor in the data center also, right? Like user grouping, there is a data center grouping, which is equivalent to a number of simultaneous requests a single application server instance can support, right? That you can set using these parameters, right? And execute instruction length per request. How many instructions you can execute per request, that also you can select here, right? So apart from these parameters, there is a load balancing policy is there. I will tell you this load balancing policy in subsequent classes. But you can see the very popular algorithm, round robin algorithm. You know that round robin algorithm assign the request first one to the first machine, second one to the second machine, third one to the third machine. The three machines are there. Fourth one is assigned to the first machine, fifth one is assigned to the second machine, sixth one is assigned to the third machine. So that is the round robin policy you can select, or you can go for equally spread current execution load, right? Based upon the execution load of each and every server, the request can be shared among multiple data centers. You know that round robin is not a good algorithm, because round robin can allocate the request to the data center, but without seeing what is the load. For example, what I can do, I want to divide the load among the two students. That's a student 1, student 2. I have 6 works. So what I do, I have divided the work into two parts. One is three questions in one set, another 3 questions in another set, or 3 tasks in a single one set, another 3 tasks in another set. So what we can do here, these 3 tasks I have assigned to the student number 1. Another 3 tasks is assigned to student number 3, right? So if you see that in terms of the number of requests, this round robin algorithm perform well. But if you go for internal configurations of these 3 works, in order to complete these 3 works, you may require 1 hour. Whereas in order to complete this work, 3 works, you require only 1 minute. So in that context, if you see, the round robin algorithm is not better, right? Because you have distributed with respect to the number of user requests. So with respect to the number of user requests, you are performing well. But whenever you are seeing their internal details, how much instructions, how many instructions are executed per request or per second. So if you see the number of requests is whatever we have requested, that is takes more time in the case of student 1, while submitting the student 1, it is not doing well in the student 2, right? It is doing well in 1 minute of time, it can be solved in the student 2. So such type of problems can happen in the round robin. So you may see that, for example, if I divide this 6 into part 1 is with 1 request, another is with 5 requests, and I will assign 5 to the student number 2, or 1 to the student number 1, or 1 to the, let's say, machine 1, let's say, and the next to the machine number 2. So they can solve in 30-minute time each, right? So that is a better algorithm, you can see, in comparison to the round robin algorithm, where we are relying on the load of each and every request rather than going for equal number of requests, right? So there, if you see, the equally spread current execution load algorithm is performing better in comparison to the round robin algorithm, right? The last one is the throttle scheduling. In the throttle scheduling, you have a specific threshold. For example, if you will take multiple virtual machines, if you are taking multiple virtual machines, let me take virtual machine 1, virtual machine 2. So you will assign some load to virtual machine, you will assign some load to virtual machine 2, and subjected to a particular throttle threshold, right? So once you can see, you can allocate the resource to the virtual machine until that threshold is reached, right? But once the threshold is exceeded, then what you have to do, you have to put all the requests in the queue, and whenever a virtual machine is free, in that case, you are going to allocate the resource as a request to that particular virtual machine. So that is the job of the throttle scheduling in the, that is also very popular load balancing policies, right? But most of the default configuration is taking round robin, so I will not be changing anything, right? So this is all about the configure simulation button, right? So let us click done. So now you have understood what is configure simulation, I hope, right? Let us go to the second button very quickly. In the define internet characteristics, there is 2 metrics. One is delay matrix and the other is bandwidth matrix. And you know that whenever a request is transferred from one region to another region, there is a communication time, right? So if it is within the same region, somehow the communication time you can say negligible. But whenever it is moving from one region to another region, definitely there is some time, right? So randomly we have picked some value. For example, if you are communicating between your own region 0 is communicating with region 0, the delay time is 25. Region 1 is communicating with region 1, it is 25. But whenever region 0 is communicating with region 1, it is 100. but whenever it is communicating with region 3 and 4, it is more, that is 250. So this is the delay matrix where units are nothing but a millisecond, right? And you can set this delay matrix whatever values you want based upon your configuration, data center and user base configuration, and how close to each other, how much time they will take. Based upon that, you can select this delay matrix, right? And you can see the available bandwidth between the regions for the simulated applications also mentioned here. So here the units are represented in the form of Mbps. So you know that whenever you are transferring the data from one computer to another computer or one location to another location, it takes time, right? Similar things here, if you see the region 0 is communicating with other regions using this particular bandwidth, right? So these things also you can set as per your requirement. These two things you can see here. Okay. So let me, this is failed to say because we have not modified anything, so I don't want to say. Now I want to click run simulation. If you click run simulation, before that, just I want to tell you, yeah, we have taken the load balancing policy as round robin, and in the main configuration, we have selected the server record policy is closest data center, right? So you can also save this configuration. Suppose I want to save this configuration. So I'm writing nitw.sim. Okay, the extension is .sim. .sim, that is the simulation. Okay, the cloud sim, cloud simulator. That's the extension is .sim. So you can save in a particular folder, right? So that the same configuration you can require during the time, right? Otherwise, once I exit this configuration, may not be there. It will go to the default configuration, right? So let us done. Then let me click the run simulation. If I click the run simulation, now it is processing. Okay, you can see the user base 7 and user base 1 is allocated to the data center 1. User base 2 is assigned to data center 2. User base 5 is data center 5. User base 4 to data center 4. User base 3 to data center 3. User base 6 to the data center 6. Because it closes data center policies, but if their average response time, maximum response time, minimum response time, it is already calculated. You need not bother about these values. The simulation is already set up, so these values are automatically generated. Everything, these codes you can get from the NetBeans folder, so that if you want to know how they are calculating, you can get the details from that folder, right? So that is the closest data center policy. So once the simulation is done, you can see there is another button here that is called as display detailed result, right? Button is active, which is not there previously. So if you go for the report, you can get the details here. Like you see overall response time summary, right? What is the overall response time? What is the data center processing time? Everything is mentioned here. The average value, minimum value, and maximum value. And with respect to the user base, you can also get the average time, minimum time, which is shown here. You can see here 51.0 milliseconds, right? These things are also you can get from here, right? Like UB3 case, you can see average value is 49.9, which is available here, right? The same thing is available here. The maximum value is 60.4, yes, it is available 60.2.9, it is 42.9, right? It is 42.18, okay? So these values you can analyze. Their graphical representations also you can get with the cloud analysis. Similarly, for the data center case also, what is the average time, minimum time, maximum time also you can get with their graphical details, right? And okay, and you have already set the cost and peak hour in the data center configurations. So the virtual machine cost is calculated as $2.09 and the transport cost is $0.08. So the grand total you have to pay $2.17 to the cloud service provider, right? And okay, the details about the virtual machine cost, the data science provider cost with respect to the data centers is mentioned here, so that you know that which data center, how much cost is calculated. That details also you can get from this particular tool. Okay. Okay, and this is all about CloudSim. Okay, you can get the details from this particular paper. I said you go to this paper, especially what is the time field analysis, what is space rate analysis, how it is working, whatever we discussed, the same thing is very clearly written. And this is the complete class diagram. Actually, you are supplementary, you have studied what is class diagram. The complete class diagram, which folder, okay, which one, having what are the files, right? Like you can say user base, what are the things are there, data center controller, what are the things are there, simulation, what are the things are there. Everything you can get from this class diagram. So that whenever you want to access a particular Java file, you can see this particular class diagram and you can open that respective folder. This thing I will share you this particular one. Okay, they have given that what is the region 2 is North America, region 1 is South America, region 2 is Europe, region 3 is Asia, region 4 is Africa, region 5 is Oceania, right? So like that they have mentioned. Okay, irrespective of this name, you can also see the details, right? There is, for the name set, they have written some region, and based upon that, they have divided the regions, but we are not means we don't require that thing because we are relying on our configurations only, right? So please go through this particular paper, you will get the details. And also in the CloudSim, you can get these 7 experimentations. In the 7 experiments, first experimentation is there is a one data center with 50 virtual machine. Second one is there is 2 data center with 25 virtual machine. 3 is 2 data center with 50 virtual machines. Like that, different configurations are also files are available in the CloudSim. CloudAnalyst is also there in this case, but CloudSim is also there, so that you will know how to create a data center, how to create a virtual machine in the CloudSim. Some basic programming are also given in the CloudSim tool, which is completely open source, right? Okay, so this is all about CloudSim. You can export the results also, right? And I can change the optimized response time. You have to change the performance of the algorithm. You can run the simulation. Okay, we say we reload the file, we will close it and open it again. And once we open it, we load the configuration. Load configuration, I have removed the Dept file, I have opened it. Then I'm changing here to the optimized response time, just to check the performance, and run the simulation. So we can see the results about what way it says, we can compare, right? Previous result to this result, right? So almost the result is same in this case, there is no problem. But if you have multiple interfaces in the same region, then this algorithm will perform better. That is optimized response time will perform better, right? And also you can export the results here. I forgot to mention. Okay. Then here we can do the details, display details, you can export the results also, right? In PDF format or some format, you can save new local drive. Okay, all of you please explore this particular tool. If you have any doubt, you can ask.